Hello learners, myself Dr. Renuka Mainde, corporate nutritionist and counselor in IGNOU for their MSc Dietetics and Food Service Management course. Turmeric is a spice that has received much interest from both medical, scientific as well as from the culinary world. Turmeric is a rhizomatous herbaceous perennial plant of ginger family. The medicinal properties of turmeric, the source of curcumin, has been known for thousands of years. However, the ability to determine the exact mechanism of action and determine the bioactive component has recently been investigated. Let's now learn about this golden nutraceutical curcumin. Curcumin is a pigment from turmeric, one of the very rare natural product that has been broadly examined by researchers from both biological and chemical point of interpretation. While there are numerous reviews on biological and pharmacological effect of curcumin, chemistry reviews are comparatively limited. Turmeric is a spice derived from rhizomes of tropical plant Curcuma longa, which is a member of ginger family. Rhizomes are horizontal underground stem that send out shoots as well as roots. The bright yellow-orange color of turmeric comes from fat-soluble polyphenolic pigment known as curcuminoids. Curcumin, the principal curcuminoid found in turmeric, is generally considered its most active constituent. The other curcuminoids found in turmeric include dimethoxycurcumin and bidesmethoxycurcumin. In addition to its use as a spice and pigment, turmeric has been used in India for medicinal purpose for centuries. Recent evidences that curcumin may have anti-inflammatory and anti-cancer effect has been renewed scientific interest in its potential to prevent and treat disease. Learners, let's now understand the chemical structure. The International Union of Pure Applied Chemistry names curcumin is 1E6E17 bis 4-hydroxy 3-methoxyphenyl 1,6-heptadene 3,5-dione with chemical formula C21H20O6 and molecular weight of 368.3. Curcumin can exist in at least two tautomeric form, constitutional isomers that readily interconvert, keto and enol. The enol form is more energetically stable in the solid phase as well as in the solution. It has three chemical entities in its structure: two aromatic ring system containing O-methoxyphenolic group connected by 7 carbon linkers consisting of an alpha-beta unsaturated beta dicaton moiety. In relation to the solubility properties, curcumin is soluble in alkali or in extreme acidic solvent. It is a crystalline compound with a bright orange-yellow color, so it is used as food colorant. It is a keto-enol tautomeric compound with a predominant keto form in acid or neutral solution, and enol form is predominant in alkali solution with good properties at chelator of metal ions. Different activities have been directly associated according to keto or enol form of curcumin. Besides curcumin, there are other components in curcuma longa called curcuminoids group. They are dimethoxycurcumin and bis-dimethoxycurcumin. Curcumin is most abundant of all curcuminoid group, and this group constitutes around 5% of total component, and this group constitutes around 5% of total component of curcuma longa. Sources: the rhizome of curcuma longa herb is the source of turmeric. The principal yellow pigment present in the turmeric root, which is identified in early 1900 by the scientist. Its structure and biochemical analysis revealed that about 2.5 to 6% of turmeric contains pure curcumin. The commercial turmeric extract contains many other components, including 3 main types of curcuminoids. You can see their name on the screens. In addition, 4 identified termerons. They are alpha termerons, beta termeron, AR termeron and aromatic termeron. Learners, let us now learn the metabolism of curcumin. Numerous studies evaluated that curcumin undergoes metabolism in different components after oral administration in animals. Because of its metabolism, curcumin has demonstrated poor bioavailability after oral dosing in animals, which may be related to its inadequate absorption. Curcumin bioavailability may also be poor in humans, as indicated by pilot study of a standardized curcuma extract in colorectal cancer patients. After oral dosing, curcumin undergoes metabolic O-conjugation to curcumin glucuronide and curcumin sulfate and bioreduction to tetrahydrocurcumin, hexahydrocurcumin, octahydrocurcumin and hexahydrocurcuminol. In rat and mice, in vivo and in suspension of human and rat hepatocytes. Reduced curcumin also subjected to glucuronidation into curcumin glucuronide, hydroxycurcumin glucuronide, tetrahydrocurcumin glucuronide and curcumin sulfate. Research studies reported that major biliary metabolites of curcumin are glucuronide of tetrahydrocurcumin and hexahydrocurcumin in rats. A minor biliary metabolites was dihydrofurulic acid together with the traces of ferulic acid. Numerous studies have revealed that curcumin metabolites have antioxidative, anti-inflammatory and anti-cancer activities. Tetrahydrocurcumin inhibits radiation-induced lipid peroxidation and induced antioxidant enzyme in vitro. Hexahydrocurcumin also induces cell cycle arrest in human colorectal cancer SW480 cells. However, the free radical scavenging activity of octahydrocurcumin is higher than curcumin. Besides this, it has been recently reported that none of the curcumin, mono or diglucuronide, showed a biological activity such as anti-inflammatory or anti-proliferative activity compared to curcumin. The curcumin metabolite curcumin sulfate has shown to have less biological activities compared to curcumin. Curcumin sulfate inhibits prostaglandins E2 activity very poorly than curcumin. Thus, these studies indicate that after metabolism of curcumin, its different components show a biological activities that differ from parent curcumin. Let's conclude, learner. Hope you have enjoyed learning the basics of this wonder golden functional food, turmeric. Curcumin, the principal curcuminoid found in the turmeric, is the most active constituent. In our next module, we'll be learning about the bioavailability of the curcumin as well as the effect of processing.